A student in a laboratory uses the apparatus shown in figure to determine the specific heat capacity of aluminium. The readings obtained in the experiment are given below. Mass of aluminium block is 0.930 kilograms. Electrical energy supplied is 23,800 joules. Initial temperature of block is 13.1 degrees Celsius. Final temperature of the block is 41.3 degrees Celsius. Use the readings above to calculate the specific heat capacity of aluminium. State the equation you use. Like any other calculation, we must first identify the givens. We have 0.930 kilograms, this is the mass. We have 23,800 joules, this is the quantity of electric energy, which is also the amount of heat energy Q. We have 13.1, which is the initial temperature, 41.3, this is the final temperature. According to these givens, the change in temperature delta theta or delta T is 41.3 minus 13.1. So this gives 28.2. This is the change in temperature. The mass is 0.930 kilograms. This is the mass of the aluminium block. Q, the quantity of heat energy, is 23,800 joules. He wants you to find C, which is the specific heat capacity. We don't have too many rules in this lesson. Only C equals Q divided by M times delta T. This rule has a replacement, which is power multiplied by time and also divided by M times delta T. But we don't need this. We don't have power. We don't have time. The question gives Q directly. Q is 23,800 joules divided by 0.930, which is the mass, times 28.2, which is the temperature change. This gives the final answer of the specific heat capacity, 907.5 joules per kilograms degrees Celsius. 1 mark for stating the equation, 1 mark for the substitution, and 1 mark for the final answer. Question B. He carries out the experiment again by supplying the same quantity of electric energy. This time the temperature readings are: initial temperature of block 41.0 degrees Celsius. Final temperature of block is 62.1 degrees Celsius. Use these figures to calculate a second value for the specific heat capacity of aluminium. We will do the same thing. The only thing that is different is the change in temperature. This time, the experiment was repeated in different temperatures. Our initial temperature now is 41.0 and the final temperature of the block is 62.1. Mass is the same, electric energy is the same. So now delta theta or delta T will be 21.1 degrees Celsius. This is different from before. Mass is the same, Q is the same, and he wants you to calculate another C. C equals Q divided by M times delta T. This equals 23,800 joules divided by the mass 0.930 times 21.1, which is the change in temperature. This gives a different answer than A. Now the specific heat capacity is 1,212.8 joules per kilograms degrees Celsius. This question is only for 1 mark. No marks for the steps because you already did this before. Question II. The student did not make any mistakes when taking the readings. Suggest why the second values for the specific heat capacity of the aluminium is greater than the first. Okay, let's compare between the two experiments. Experiment 1 in A and experiment 2 in B, I. Q is the same in the two experiments. M is the same in the two experiments. The difference is in the change in temperature. Experiment 1 was starting from 13.1 degrees Celsius. heating until 41.3 degrees Celsius. The second experiment in B was starting from 41.0 degrees Celsius up to 62.1 degrees Celsius. This causes different calculated value for C. The reason is the second experiment was carried out at higher temperatures than experiment 1. So the amount of heat loss in experiment 2 is greater than in experiment 1. This larger amount of heat loss in experiment 2 causes larger error in the experiment. So the final result has a greater amount of error. So we say that working temperature is higher, so greater amount of heat loss and larger error.